Hi folks, 2018 question C1 here, and what we're looking at is a toll plaza, and we've got a plan view there of the way the ground widens out to accommodate that. Now we're given certain piece of information in that the embankments were 1:2, the cuts is 1:1.5, and when you scale them up, of course, that means the embankments are filled, becomes 10 millimeter spacings the lines, and the cuts will be 7.5. We're told from C to D over here that the road is rising, so it's level all the way at 65, and then it's rising from C to D, and it's 1:15. So when you scale that up, if you come down 75 mil along the road, which I have already done here, it'll go up 5 meters in altitude. So this guy will be 70. At that point there, it'll be 70 as well. This guy will be 65 down here. Now, the next thing you ask yourself is a cut or fill. So remember the saying, cut at the butt, fill at the hill. And I've done out all the very basic parts of the road where it was level, okay, because that's relatively simple stuff. So down here then you ask yourself, cut or fill. Well, actually you've got both going on, and I've just partially set up this just to save some time on the video. So you can see the way when it starts at 65 there, it's too high, okay, and somewhere around here it gets too low. So we're going to actually have to put in cut and fill on this little section, which is quite unusual, and it might be a bit messy, but we'll get it done anyways. So I'm going to worry about the fill part first, so I have that bit set up. So set your compass to radius 10, draw in your semicircle here. Why? Because fill at the hill, okay? So we'll just worry about this piece first of all, and then we'll worry about the cut, okay? So I marked it off. Remember, it's always getting lower, 65, 60, 55, 50. And we'll go ahead then and we'll start marking out our points there. Now, they might overlap. Sometimes you might need another point. If you do, we can just drop that down there. That will get us 70. So just drawing that line, not too heavy for the time being. And now part of this is cut. Okay, it's too high. So cut at the butt, this is the lower point, that's the higher point. So set your compass to 7.5, I've already done that there. Press down your compass and we'll draw our little plan view of our semicone. And I'll just shade that in there. And now from over here, we'll run off our tapered line and we'll space these guys out at 7.5 mil intervals. And what we'll be looking for, of course, is a place where they crisscross. Let's run on them lines a bit extra. So we're looking for the crisscross, this line, red line we already have, and this blue line. Now, so that one there is 70. 75, 80, 85. And I don't think we need to go any higher than that, okay? So let's just start off. Actual fact, I just had to finish out this guy from earlier on. So we're looking to cross that existing red line now and this blue line. So 70 will give me a point here. 75 will give me another point here. Here. 80 there. So I find out that's already where that guy crisscrosses there. Okay, so that's a very important point. And then if we go the other way, we just need to drop this down. That'll give me a point. That guy, that's 65, of course, coming from here. So now we've got the point there where the two crisscross here and here. So we'll just go then and we'll put in our symbols. And that is the drawn part of the question. So just remember that, cut at the butt, fill at the hill, and you'll be grand. Now, if we just go back to the question here, and I'll roll down, it's telling us part B on a map, P, Q, and R are 3 points on the surface of the Earth. So there they are there. I already went ahead and just joined them in. Vertical boreholes at these 3 points reveal a triangle on the top surface of a stratum of ore at altitudes of 45, 60, and 35. So I always just write in them. There's no harm either, I think. And then it's saying, in the space provided at the top of the map, draw the elevation of the triangular portion of the top surface of the stratum. Okay, so they already kind of had to start for you there with them altitude lines. So I just came along then, and earlier on, and I just did a few more of them. So you only need to go up as far as 60. That would be our max height. Okay, so this is getting us R here. It's at 35. Q is at 60. And we have P here at 45. And we'll join them in then. Now the next part, the reason we need that as well, is the next part we've been asked to do is to get the strike and dip, okay? So we're going to need to see an edge view of that to see the dip, but we have to find the strike line first. So what we always do is we take a level line across there. We'll drop them down onto the line QR, which will be here. You drop it down. And this will get us our strike line. So I just put an S there for strike. Now, another handy thing about that is that now is a true length line. And if you want to see a plane as a true length, you need a true length line and look along it, and you'll see it as an edge view. And that way we'll find the dip as well. So get your set squares there. Line them up. Actually, I'll just get the bigger set square. Set in our x1, y1. Now Q with a height of 60. So we can mark that off there. Or the height of 35. If we just join them in there, this will get us P here. So that there is the dip. That angle there. I'll just put a D in there for dip. Now, that's part, the last part done. Just to go back to the part C, then it says there's a third part to part B. Determine and indicate in meters the length of the shortest skew borehole from or to the top surface of the stratum. Okay, or has a height of 80 there. We can see it sitting on that contour line. Okay, so if we measure up 80, that will be the top up there. Okay, now that's where we got that point, was when it drilled down. Okay, that's where we got that height of 35 from. But if you were standing up here, drilling down, that is the height you would be above, or when you hit the top surface. So the shortest distance, you could pick any point along here, and even the surface can extend on. That's just a portion of the surface. But the shortest distance, of course, would be at a right angle to it. Okay, so that is the shortest distance there. And you can throw a measurement on it if you want, just in case. I think it said indicate in it. Indicate in meters. So I make it 32 there, or if you just mark distance down there at the very least. So that's that part. Now the last part then we're coming up to is C, and it says determine and plan the line of intersection between the top surface of the stratum and the surface of the widened portion of the toll plaza. So when they drilled down there initially, they found this top surface of the stratum of ore. Okay, now we know when the car park is made, then it was made at a height of 65. Now that is just a portion of a stratum. Okay, so it could extend on downwards for God knows how long, and it could also go upwards. So if it did go upwards and the car park was finished, the car park is at an altitude of 65. And it's level ground. So the car park would be going along like that there. If you were to extend up, then this ore, when they were digging down, could have come up and could have hit the car park at that point there. Okay, and if you were to represent that back then in your plan view there, we'll do it like so. Just run this guy back down. And that is how he will be represented in plan view. Okay, so that's that question finished, folks. I hope you found it useful. Take care, stay safe, more videos to come.